So someone asked me the other day if it would be possible to explain how to build your own custom controller. And in fact, we've had a couple of people ask, would it be possible for us to do some DIY videos? And so I decided to start a new series called On Your Dining Room Table, which is exactly about that. What kinds of cool things can you build on your dining room table without needing, you know, a giant garage or a place that you can spray or 3D printers or laser cutters or any of that stuff. And of course, we will include some information about, you know, how to do 3D printing and so on, because, you know, some people do have those things lying around, and actually a 3D printer doesn't require you to have special manufacturing facilities. You could run it on your dining room table. But anyway, we're going to start a series of videos first about making your own custom game controller, right? This is something that's actually remarkably easy to do. If you would like to, for example, build your own fight stick, or, you know, build a mini arcade console at home, or even just build, you know, a handheld NES style controller in a particular set of colors and things that you want. It's actually something that's pretty cheap and pretty simple to do, and it can be a lot of fun because you get to decide everything about the project, right? The colors of the buttons, the layouts of things, how many inputs you have, and all that stuff. So for this video, we're going to show you the kind of theory behind how to build a controller, the kind of electronics ideas behind it. We're going to walk through some of the parts that you will need to buy, and then some of the essential tools that you'll need. And we're going to try and keep everything as cheap and simple as possible. So in order to keep things cheap and simple and as general purpose as possible, the controller that we are going to build is going to be a USB HID controller, right? HID means human interface device. It's one of the standards that USB offers for doing inputs for human interfaces, right? Things like joysticks, keyboard, mice, etc. And so it's very cheap today to build essentially a USB joystick / keyboard / mouse so that you can wire up whatever input. So what we're essentially going to do is we're going to build ourselves a USB joystick using whichever kinds of switches and joysticks and so on we want. So what about tools? What tools should you be getting in order to complete projects like this? Now, the tools I'm going to show you are going to be the ones that are required for the project of building your own controller, but really they're going to serve you for pretty much any electronics project you want to do. So if you're going to get into modding or building in this way, this is all stuff which is going to last you a really, really long time. And all the tools that you see here are things that I used, you know, for ages, like 2 or 3 years before I decided to upgrade to something more expensive. And again, we're going to try and keep things cheap because, you know, you might get into modding and decide you love it, and then you want to go and spend all your money on tools and equipment, which is great. But if you decide, it's not for me, we don't want to have, you know, spend too much money on that. So the kind of essential things that you need are laid out here. First, I'll show you the essentials, and then I'll show you a couple of cool optional things to get, which can really help. So the first thing you're going to need is going to be a soldering iron. That is absolutely essential. You cannot work on electronics without soldering. Soldering is what allows you to make the connections between components and also keeps everything kind of nicely, you know, held together so that things don't pop open and you have issues later. So this particular soldering iron is the first one that I got and I started modding with. I even did my mod of connecting a cartridge port to the Atari Flashback, which is actually some fairly detailed work. I was able to do it with this soldering iron just fine. So this particular one I got at Radio Shack. You can find them at Amazon or eBay. You can pay about, you know, 15 to 20 bucks for this one. So what you're looking for in this is you don't need anything fancy. To begin with, the kind of stuff you're going to be doing, you won't need to have variable temperature control or any of that kind of fancy stuff. This one really has got 2 modes. It's got a low and a high. I would always use it at the high, which is a 40-watt mode. What you are looking for, though, is you want a soldering iron that's got a fairly small tip like this one. Don't get the ones that look like a gun that has a kind of loop at the front. Those are for electrical work, not electronics, so it's for soldering really large cables. You need a tip that's going to be small like this one, because ultimately you're going to be soldering in some pretty small things together. If you look at the legs of these components, like if you look at the holes on the Teensy, you can see they're pretty small, right? So you want a soldering iron that's going to be able to get in there without kind of, you know, bridging across 6 of them by accident or anything like that. So you're looking for something with a small tip and that can do like 20 to 40 watts, and that's about it. You know, you can pick that up for 15 to 20 bucks, Amazon or eBay. I'll move that out of the way. Now, in terms of other smaller things, The other things that are absolutely essential are the things that are laid out here. So the first thing you're going to need is a set of wire clippers like this one. This one is an Italian brand. I forget exactly what it is. CHP, I think it is. Oh no, this is not an Italian brand. This is, you don't have to get anything fancy at all. $4 or $5 at Amazon, that's about it. This is necessary because you're going to be clipping a lot of small cables. And you want to make sure that they cut cleanly. Some people use scissors. The problem with scissors is, apart from the fact that you screw up your scissors because they're not designed to cut the metal cords inside this, the clippers allow you to essentially cut without sticking the point of the scissor very deeply in like this, right? You can put it right to the point where you need and then just give it a clip. So that makes them very cool. You will be using these a lot. It's definitely worth spending your money on those. As you saw, another interesting piece of equipment that you should get is an Exacto knife like this one. These knives come in two sizes. I think it's 11 and 22. The 11 is the small one and the 22 is a bigger blade. I get the 11 because it's handy for all kinds of other craft projects around the house. The reason you'll be using this is because the other piece of equipment you will need is this, which is ribbon cable. This is regular old ribbon cable. I pick these up at Goodwills and secondhand stores from old PCs. Often they will have a big bin with like old IDE or floppy cables. I just pick up a bunch of those and I use this as the cables inside my projects. And because they come in a ribbon, you're going to need to separate out single strands. So what you do is you cut between two of the things and then you can kind of separate it out. And there you go, you got your strand of cable, right? So very handy for just kind of generic cutting and scratching, etc., that kind of thing. So very handy, and you will be needing a lot of this cable because everything is connected to something else, right? So you got to have cables between them. So pick up a bunch of these from a Goodwill or something. The other thing you'll need if you're working with arcade buttons or any of that kind of thing is either a little spanner, which is, you know, it's simple enough to get, but I use a pair of pliers like this. So what I do is, you know, if you're trying to tighten something, like I'm trying to tighten the nut on this, I can actually do it going like that, right? You kind of nip it through and then you tighten it. The reason I do that and not a spanner is, well, when you're tightening these, it doesn't require a huge amount of force, and it's a set of pliers like this is very general purpose. You can use it for a bunch of things. So yeah, I'm sure that there are people out there cringing saying, oh no, right tool for the right job, you should be using a spanner. Okay, yeah, sure. But if you're trying to keep things cheap, this little guy can get the job done. It's only a couple of bucks on Amazon, and then I can get my things done. And then the final thing, which is quite important, is this, which is just regular super glue, right? This is cyanoacrylate. You can pick this up pretty much any hardware store and probably place arts and crafts stores as well. This is handy for a number of reasons. It dries very quickly, so it's very useful for just kind of, you know, being able to build quickly without pausing. You could use hot glue for a number of applications in projects like this, and I do have a hot glue gun lying around, which I use a lot. But if you're not going to be heavily building things, a hot glue gun is just kind of messy and large and can be expensive. So I use this for example, if you are trying to wrangle a cable along a particular path, you can just put a dot of super glue and then glue the cable in place. Or once you've tightened screws, for example, you've put your joystick onto the board and you've tightened the screws and nuts, and now you don't want them to move from the vibration of using it, you can just put a spot of super glue between the screw and the nut and that'll hold it in place. So it's very handy. It's got a lot of things, a lot of uses, not just for the projects you're going to be working on, but around the house again. One thing about super glue though, it is activated by humidity, and your fingers have a lot of humidity in them, of course. So if you are using this, get ready to glue yourself to various surfaces, right? It will happen. They say on the package, you know, be careful not to glue yourself to stuff. Yeah, it's going to happen eventually. So the trick is, whenever you're gluing, make sure you don't put, like, you know, your whole hand down when you're gluing things. Make sure that you do it with as little skin surface as possible. What I will recommend doing is, one of your optional tools, which is not required but super handy, is a pair of just tweezers. So that way, if you are going to be gluing something, you can hold it with the tweezers and then, you know, apply the glue like that and get your fingers out of the way. If you do get yourself stuck to something, most of the times you can just lift your finger off. It's not a big deal. But if you find that it's really sticking to it, you've got two options. One is to go to a doctor and get them to help you out with it. The other one is to get your Exacto knife and try and cut yourself free. I do not recommend doing that. I tried it once and it went very badly. In almost every case, when I've been gluing something, I just kind of touch my finger and then lift it. So don't leave your finger on there for very long and everything should be fine. This stuff, however, is super poisonous. The main component of it is cyanide, so make sure you don't have any food or drink around when you're working with it. So two more things which are important. This is a multimeter. I'm not going to say it's essential because they can be expensive. This particular model is kind of expensive. It's more than $100. I kind of splurged because I use a lot and I thought, oh well, it's time to upgrade. The original model I had cost me 20 bucks. What this does is it allows you to measure a bunch of things, and it basically enables you to debug your project. Like if you've wired everything up and then it's not working and you're trying to figure out, do I have a loose connection, this will let you debug. It's got a couple of interesting things. The mode that you'll end up using most often is what's called continuity mode. So let me show you what that looks like. So the multimeter comes with these probes, which is what you use to measure things. Continuity mode basically will sound the beeper inside the multimeter if you've got connectivity between 2 points. So if I just touch my two pieces together, it beeps, right? And so what this lets me see is if I have a cable, you know, we can do it on this, actually we'll try it on this piece of solder. So I want to see, is it connected correctly? Then what I can do is just touch on either side of it and that'll beep saying, oh yeah, no, that is totally connected, right? Stood over here. So yeah, that's connected correctly. And when you've got, you know, 10 buttons in your project and you're trying to see why isn't that button working and you're trying to debug it, often the answer is you soldered it wrong or the solder joint doesn't quite make a connection. So you can just kind of probe and touch and figure out where things are. So very, very handy. If you are planning to do more than one such project, I would strongly recommend you get one of these guys. A cheap one to begin with. What you're looking for really is one that has the ability to measure voltage, current, so in other words amps, resistance, which is ohms, and then continuity, which is the beeping I just showed you, right? Those are really the only functions that you're going to use for most of your projects to begin with, so strongly recommend it. Another recommendation for a tool is this little guy. This is a wire stripper. The way it works is you kind of unlock it. Let's get a piece of wire to strip. So of course if you're going to solder wires, you need to strip away the plastic insulation to get at the metal. People do this on their teeth, you know, and I did that for a long time. It's not great for you, as you can imagine, and if you're going to be doing this a lot, it's actually kind of annoying to do that. And also it's very hard when you're biting your way through something, you know, like a hungry dog, to get nice consistent results. So a device like this can help. And the way it works is it's got those little kind of round semicircle indentations, which actually each of them are sharp. So what we do is we line it up to the right one here, to the right size for this cable. And when you pull, you see you get this beautifully stripped cable end. Don't know if you can see that. And now that's ready to solder, right? So very handy piece of equipment. These unfortunately are a little expensive. I think this one was 35 bucks. But if you plan on doing this a lot, you should definitely get one and then look after it very carefully. This one you'll notice has got this little clip to keep it closed so that while it's open it doesn't get its little sharp bits blunted. And then the final piece of optional gear is this little guy. These are actually pretty cheap. They go for like about 10 or 15 bucks. What these are is essentially little alligator clips on a stand. And what these let you do is essentially hold things while you're soldering. And this is important because soldering, unfortunately, is like a 17-hand job. You essentially have to get your solder, right, which is you buy this soldering material, which is pretty cheap. You pay like 10 bucks for a roll that'll last you for 7 years. Then you get your soldering iron, and what you need to do is hold the solder to the soldering iron and the part simultaneously to get the solder on there. So, you know, without something to help you, it's kind of hard. You can try resting it on your work surface and bending it like this and then kind of applying it. That works pretty well. But eventually you're going to get into a situation where you can't angle the thing correctly, and then you want to have an extra pair of little helping hands like this guy. So this is called a helping hands. If you can search for on Amazon, they are pretty cheap. Some of them bring a little magnifying glass on top. Magnifying glass is not worth very much, but you know, this can be handy if you're finding it frustrating getting all your pieces lined up. Okay, so let's look at some of the parts that you're going to need in order to make your own controller. Now, we'll start off with the star of the show, which is going to be this little guy. This is going to be the microprocessor, which we use ultimately to take the signals from the various switches and buttons and then convert them into USB HID signals that your computer is going to read. So this particular guy is based on the Atmel AT, I think it's a 34U8 or 32U8. This particular board is called the Teensie Teensie++ 2.0. It's made by a small company in Portland, Oregon called PJRC. I'll put the link to them in the description below. What makes this particular board really nice is that PGRC ships software with it that lets you program the USB behavior really, really simply. And it also has 46 I/O ports, which means we can add lots of different buttons and inputs to it without having to do any fancy electronics. So it makes it really easy. This little guy will turn itself into a 32 button 6-axis joystick with a hat controller on top. It'll also do a mouse with scroll wheel, or it can impersonate a USB keyboard, and it can do some combination of those at the same time. So for example, you can send joystick and keyboard signals simultaneously. When we do the video on programming the software, we'll talk about all that kind of stuff. So it comes inside a nice small form factor as well. I've soldered headers onto this one. You don't have to do that if you want to keep it smaller, but you could even do a handheld controller about this size, right? So if you imagine you've got a kind of NES style controller, this could very easily fit inside, or you can do it inside a great big arcade controller, right? So this is actually a very, very nice little device to work with. It's got 8K of RAM, which means you can do as much logic and lookups and various things as you want. So very nice little thing. It goes for about $25, so very affordable, very cool. Then once you've got the microcontroller set up, now we've got to talk about inputs, right? So essentially we can handle either digital signals, so things like key presses or button presses, or we can do analog signals, things like joystick axes or the axes of a mouse, right? So for doing analog signals, we're going to use a potentiometer, which is like this one. I'll show you about this one in a little while. Essentially, these are controls that let you set a level of resistance. So as I turn this little pin on top, I'm changing the internal resistance. And then the Teensy, if you just connect this directly to its pins, is able to measure that, and you can convert that to say, oh, the joystick is, all the way to the left or all the way to the right super easily with a single line of code, right? So that's going to be our part that we use for analog signals. Now for digital signals, we've got a ton of choices. Generally, we're going to either want to use a joystick or buttons, right? So let's start looking at the buttons. If you're interested in building arcade type controllers, then the best thing to do is to buy an actual arcade button. This is a good example of a typical arcade button that you can buy. I picked this one up on eBay. You can find them at Amazon, other places. This probably goes for $3 or $4. You can find ones which use a less kind of bulky switch like this one, which go for about $2. So this is kind of the traditional one. The way this works is you've got this large plastic piece on top, which is the actual button itself. It's got this ring at the bottom, which is used to secure it to the mounting board. So you kind of drill a hole in the mounting board, insert this, and then screw the thing up from below. We'll show you that when we get to the video about doing the physical design. And then at the bottom you've got this guy. Let's flip it around so you can see. This blue thing is called a micro switch. It doesn't seem very micro to me because it's pretty big, but anyway, that is a micro switch. That is what does the magic, right? As I push this, it triggers the switch internally. When you buy these, they usually come disassembled, something like this. You get a baggie with all the parts. So I'll show you what that looks like. So you get 3 parts inside. You get the actual button. This is just plastic and a spring. There's nothing magical in there. It's got this form at the bottom, which is what actually allows you to clip the button in. So you kind of squeeze it in there, the other way around, and then it clips into place. I won't do that because I want to be able to use this switch to show you how the switch works. And then once that's in place, you kind of stick this in and you screw it into place, and this is what holds it to the control board above. Okay. Now if you want to go for something, as I said, yeah, there's this other style which instead of having a large micro switch outside has got a built-in switch over there. It's got 2 pins over here, which is what we'll use for detecting. It doesn't make the large clicky sound. It's a different kind of switch style. What I like about these, apart from the fact that they're a little bit cheaper, is that they're actually significantly shorter, right? So if I hold these side by side, you can see this one takes up less space vertically than this one does. So, if you've got a project that you want it to be a little flatter, then you should be using this one rather than this one. Then going down, there are many, many different kinds of digital switches. We'll go into the technology in a second. There is this one, which is a kind of mini arcade switch almost. I think it measures 6 millimeters across. It just pushes, and you've got the 2 pins at the bottom. And like the arcade switches, you've got this nut which you use to kind of attach it to the control board above. You also get this style of arcade button, which can be very cool for certain applications. So what makes this one special is that you've got a light bulb, which goes inside the button itself. So you screw the light bulb into this plastic device, This clips into place, and then the switch goes there. So basically this will get you a backlit illuminated button while you're playing, which can be quite cool if you want to make a, you know, a track mode or something flashy like that. Otherwise it works exactly like the other arcade buttons apart from the light bulb. And then if you are thinking, okay, I'm not really interested in doing arcade style controls, I want to do like a handheld controller, like, you know, you want to do a NES style controller, then there are a whole series of smaller buttons you can use. You can also get a micro switch just like the ones in the arcade button, which are just smaller. So they work in exactly the same way, they're just a smaller size. This is a kind of barrel type button, just like this one, only smaller. Same kind of thing, it's got a nut you secure to the bottom. And then you've got these which are called tactile switches. These are probably the smallest ones that you can work with. It's just a little block with a pin, and when you press the pin, that's where the button is. Very, very simple. You get them in this size, which is I think a 4mm size, and then you get these little teeny tiny 3mm ones, which are probably the smallest ones you can find, right? So just hold these side by side so you can see the difference. Very cool little switches. If you want to do a traditional game controller type thing, you can actually glue these onto the surface and then put a button, glue a piece of plastic above to be the button, and that's how you can do that. And then the final one is this one, which is very cool. This is actually a 4-axis joystick with a center click. So if you wanted to do a kind of like the analog sticks on the Xbox 360 controller except digital, you can do that with this. It's got lots of legs at the bottom because of course it's got essentially 5 switches built in here. The final thing that you might want to use is of course an arcade joystick. If you're building an arcade style controller, you're going to need a joystick. This particular one is from Sanwa, which is a pretty good company for making arcade parts. So a lot of professional, you know, actual arcade parts. This is a real arcade joystick, by the way. Picked this up on eBay. I think this was about 20 bucks. It's got a lot of instructions in Japanese, but it's super easy to use. Don't worry if you can't read Japanese. When you open it up, you get the joystick inside a box, and then of course you get the ball on top, which you will then screw on here. Most places that you buy this from let you pick the color of the ball. So, you know, if you want whatever color scheme you're using for your project, make sure you point that out. And then if we free this guy from his baggie, let's take that ring off. This is the joystick itself. So you basically have this aluminium part which has got this hole template. So in your project you would drill holes at the right, you know, separations, and then you could put screws to attach it to your board. At the bottom it's essentially got 4 of these micro switches, just like we saw on the joystick buttons. And then when you move the joystick around, it triggers each of them, right? The Sanwa sticks are nice because they come with a wiring harness. So you just kind of connect this to here. You got to do it the right way around though. Let's get all these guys in there. Oh, there we go. And then it exits out here, right? So you've got everything kind of nicely color coded, and you can solder this directly onto the Teensy for reading the signals, which is pretty cool. So before we kind of look at exactly how these buttons work and what we can do with them, let's go over to the whiteboard and understand the theory of how we can turn, you know, the Teensies Atmel chip into a USB controller. Okay, so let's understand first how the Teensy or the Arduino or whatever microcontroller we're going to use actually reads a signal from an external device like a switch or a potentiometer, right? So let's say that this box here is our Teensy, and it's got a number of digital input lines that we can connect a switch to, right? So let's call this one D1, and somewhere up here we have a ground line on the Teensy, or it's called common sometimes. And what's happening with the Teensy is we can tell the Teensy, I need you to return to me or tell me what the state of this line is. And this line can have one of 2 states. It can either be high or low, which is just the kind of electronics way of saying that it's either going to be at 5 volts or it's going to be at 0 volts, right? So the way to think about this is, you've probably heard, you know, how computers all talk in binary ones and zeros. Well, 1 is 5 volts, that's the amount of current that, or the voltage that the Teensy uses internally, and so that it counts that as a 1 or a high state, and then 0 volts is low, right? So it is possible for us to write some code, and we'll see that in the next video, to essentially tell the teens, okay, what is the state of this line? High or low? Right? And we can also tell the Teensy, by default, I want you to set this to be high. So in other words, when the Teensy is doing nothing, this line will be high, such that if we query it, we'll say, hey, what's D1 doing these days? And it will return back and say, it's high, right? And we'll show you how to do that in the code. So now what we want to do is we want to create a situation where when you press a switch, this is going to return something different to us. So instead of saying high, it's going to say, oh, it's low now for some reason. So how do we create a situation where when I press my switch, and we can draw a switch like this, right? It's open. When I push the switch closed, how can we create a situation that this reads low? And it's actually super simple. All we need to do is connect our switch to ground on the Teensy, right? So when the switch is open, it'll be reading the 5 volts from the internal setting that the Teensy has. But when we close this guy, you'll essentially be creating a short circuit to ground, which is 0 volts, and then the Teensy will read low. So basically what we're going to do in our code is we're going to say if D1 is low, then we're going to take whatever action we want to take when the button is pressed, like, you know, joystick button 1 pressed, right? Something like that. And you can do this with as many buttons as you want, right? So we can have a D2 here, which has the same theory. And because ground is common to all of these, we can just connect it to the same ground line. And D3, and so on. So we'll see how we do that when we do the video next time, to actually showing you how to connect these things. But that's the theory. And each one of these will have its own state, right? And these will be reading high now because they're open. And then when we close one, then boom, suddenly it drops to low, and our code can detect that because we have our test, our logic condition there, right? So that's how we're going to do the digital switches, and that means the buttons, and it means the joystick, the digital arcade joystick, right? So what about a analog input? If you want to do a potentiometer, how does that look then? It looks very, very simple. The difference is this, right? When we are dealing with digital inputs, if you imagine a graph here, we've got time along the axis and then the state here, the voltage on this particular input. If you're a D, you're either going to be at 0 volts or at 5 volts, right? You're going to be at 5 volts when nothing is happening, and then when the user presses the button, we're going to shoot to 0 and we'll stay there, and then when you release the button, we're going to shoot back up to 5 and so on, right? That's what the graph looks like if you're a digital switch. But if you're an analog switch, what we want to do is we want to create a situation where you can be kind of halfway in between. So if I start off with the potentiometer turned all the way to the left, I might be at 5 volts, right? And then as I turn it to 0, it's going to kind of follow whatever I do with the button, right? With the knob, rather, as I turn it. So how do we create that situation? That's very simple. The Teensy does all the work for you. You don't have to do very much. We're going to basically hook up our potentiometer in the same way. We're going to put one leg of it to our pin and then one leg to ground. So let's get rid of the digital stuff. And then there is a special set of inputs on the Teensy which are called analog. And so they have got the names A1, A2, A, etc., right? And again, they start off with a particular state, and then we put our potentiometer here, and that's the symbol for it. That looks like a little arrow. And then we hook that up to ground. So now, it's very simple for the Teensy to kind of measure the voltage that's going across here, and it will, when you do a query saying, you know, what is my analog value, it'll return a number between, I think for the Teensy, it's 0 means it's all the way to the left, and 255 means it's all the way to the right, right? So I can just say, you know, V equals analog read, for example. We'll show all this when we do the firmware video. And then, you know, V will be 0 if to the left. And then V is going to be 255 if to the right. And anywhere in between as I turn the knob, right? So that's how I'm going to set up my circuit essentially. And as you'll see when we actually get down to do the soldering, it's very, very simple to set these things up. The things that you need to remember are, for every one of your buttons, you're going to need a digital line, so a D line that we can use. And then the other side of the button will be connected to common, and all the commons go together, right? We don't need to have special one common per, it's common to everybody. And then we're going to need one analog line per potentiometer that we want. So we're going to use up as many pins on the Teensy, input pins, as we have buttons or potentiometers, and then the other side of them all is going to be going to common. Okay, let's talk about switches for a moment, right? So, as we said at the whiteboard, when you're connecting a digital switch, so be it one of the contacts on the joystick or an actual button, what you want to do is you want to essentially create an electrical connection between the input pin on your Teensy and ground, right? So you can pull the pin low. So there are generally two kinds of switches that you can buy. You get these ones which have got two terminals on them, right? You can see there's two pins on here. Or you can get these which are called micro switches that have 3 pins on them. And so you need to understand which one you're getting in order to wire it up correctly, and both will work just fine, by the way. So the reason some have 2 and some have 3 is because switches can have, they come in basically 2 families. They're either normally open or normally closed. And what that means is when you're applying no force to the button, so when it's in its natural state like this, is the electrical connection open, meaning there's no current flowing, or closed, meaning the current is flowing, right? So the way you can discover whether you have a normally open or normally closed switch is by using your multimeter in continuity mode. So let me connect that up. So I'm going to set this up to the continuity icon, which is a little sound wave icon here. Let me get my test probes and wire it up. Now I'm going to wire up the first probe. Now if this were a normally closed button, what we would expect is when the minute I connect the second probe to the second terminal, we would hear the beep because electricity would be flowing, right? And oh, there's no beep. So now let's apply force to the button. Oh, there's the beep, right? So in other words, this is a normally open button. It's normally open, and when you apply the force, it closes the connection. So this button is going to work just great, because what we're looking for is a situation where there's no button, we're not pulling the pin low on the Teensy, and then when the player presses the button, it's pulled low, and we can detect that, and then we can do our thing on the Teensy itself, right? So these are normally open with 2 terminals on them. So when you buy these at eBay, look for them to be normally open, and then you can test them very easily using continuity mode. Now what about these 3-pin ones like we have here? This one is just, by the way, already installed into the button. It's exactly the same as this one. It's got 3 contacts, so I'm going to set this aside because there's nothing special about that one. So what about these 3 ones? Now if you look at the switch itself, you can see it's got a kind of little schematic drawn on it, and what it's telling you is that this is COM, so in other words this is common or ground, the bottom one, and then these are, one is labeled NC and the other one is labeled NO. So there we go, it's already telling us this is the common port, so we're going to put connect ground from the Teensy to that one, and then we're going to have a normally open and a normally closed state. So I'm going to connect the normally closed, the NC, and you can see without pressing the button it beeps, right? Now what about the other one that's labeled normally open? Well, when I hook it up nothing happens, and then I have to push the button to get the beep. So the thing about these 3 terminal switches is that they are both normally open and normally closed at the same time. You can choose which one you want in your design, which makes them kind of handy. For most of the projects we'll be using, we are looking for normally open just because of the way the Teensy is configured. But you know, if you ever wanted to do a normally closed one, these micro switches are nice because they let you do that as well. So now let's look at the somewhat joystick. This is another kind of switch which you're probably going to want if you're making an arcade style project. So essentially what the somewhat stick is 4 micro switches, and you can kind of see them. There is one here, there's another one there, one there, and one there, kind of arranged around the shaft, and then when the shaft moves it triggers each of the ones, right? And the idea is that it's kind of reversed. So if I push the shaft this way to the left, then it's pushing on this switch here on the right. But really what they are is just micro switches internally. So what you need to do is you need to look carefully at the switches and see how they are hooked up, or you can just test it using your multimeter, right? So if you look carefully, I don't think you'll be able to see it on the camera, but there is a little bit of writing on each of the switches. And I can see that this one here says COM and this one here says NO, and then the NC has been removed. So I've got common and normally open, which means if I hook these up, I'm going to hook one, actually, I'm going to put this one on normally open, and I'm going to put the black one on common. It doesn't really matter which order you do them, because all you're doing is just closing a path. But you get into the habit of always putting the black on common. Okay, so there we go. Now, at some point, I'm going to move this joystick and it's going to discover it. I think it's going to be this way. There we go. So that is the connection for that one. And if I move it in the other angles, it does nothing, obviously. So there we go. So now I have two options. Because this is a Sunwa joystick and it brings the connection kind of harness with it, we can do it that way. Or if I didn't have the harness, now I know that these are the 2 points that I need to solder into my Teensy, right? The black one is going to go to ground. Or common, and then this one is going to go to my input pin. But given it's a Sunwa, you know, we can use the wiring harness because it saves us doing a bunch of soldering. So then what I'm going to do is I'm going to just connect this here. There we go. And now you'll notice that what we have here is 5 cables, right? 1, 2, 3, 4, 5. And the reason we have 5 cables is because there are 4 switches on here plus ground. So now I'm going to bet that black is common because that is kind of an international standard for these things. So I'm going to hook up that one. And now the question is, for any one of these switches, which is the right one? So what I'll typically do when I'm starting one of these is I will take my joystick, which is kind of arbitrary orientation. I'm going to take my Sharpie and I'm going to mark on here the kind of orientation, right? This is up and this is left. So that when I've finished wired everything up with the assumption that, you know, this pin is up, this pin is right, I can physically install it into my project at the right orientation. So now the question becomes, okay, which one of these colors is up? So what I'm going to do is I'm going to hold the joystick up and I'm going to touch each of them and see which one gives me a result. None of them are giving me a result. I think it's this orange one. Let's see. Grab that. Oh, there we go. Okay. So orange is up. And you just make a note of that on a little piece of paper and then you kind of color code them all. One thing to be careful of, by the way, when you're doing this is the beeping sound on these multimeters often has a little bit of a delay. It takes, you know, half a second or so for the multimeter to actually pick it up. And also the connections could be loose. So if you have the situation I just had where like, oh, I've tested all 4 and none of them's connected, what the hell? Recheck everything again. Make sure that your probes are tightly connected to the cables. Make sure that you hold the joystick for a good amount of time, that these things are plugged in correctly, etc. Because all this stuff, you know, even if there is a tiny bad connection somewhere along the whole pipeline, you will not get a reading, right? So you got to make sure that those things are correctly connected together. Okay, the final piece of input we want to talk about is for analog inputs, which is a potentiometer like this guy, right? So you kind of buy them in the shape. They have a body with 3 pins, 3 contacts, and then they have a shaft which rotates. And you can get them with longer shafts or shorter. You can decide which one it is. There are 2 interesting variables to potentiometers. One is the resistance that they offer, so the number of ohms, and the other one is whether they are linear or logarithmic, right? That makes an important difference. So first of all, let's talk about the ohms. The way that one of these potentiometers works is basically it allows you to set the resistance internally between the 0 or the minimal amount, and then when you turn it completely on, it'll be the maximum amount, right? So it basically lets you set a range between that, and then your Teensy is able to measure how much resistance there is and convert that into a axis deflection for your joystick, right? So they come in many different kinds. This particular one is a 10,000 ohm or 10 kilo ohm resistor. That one works just fine. You can get 1 mega ohm, you can get, you know, smaller values. I find the 10K works just fine for the Teensies. It gives you good solid readings without too much noise. But you could use the different kinds, mega ohms, etc., and the Teensy will kind of auto take care of itself, as we'll see when we write the code. Now, the linear logarithmic thing does make a big difference to your project, and this is why it makes a difference. Potentiometers are generally used for 2 kinds of applications. Audio, so in other words for volume controls in like you know, MP3 players or hi-fis or whatever it is, and then other applications. If you are building an audio application, you want a logarithmic scale, which means that that's not going to be the case that when I have it at 0 at 0, then maximum is my 10K and halfway is 5K. Logarithmic is going to be 0 0, maximum is 10K, and halfway might be 9K, right? Because instead of smoothly going up the amount of resistance with the amount of angle that I set on this thing. Instead of going up in a linear way, it goes up in an exponential way, because that is the way your ear perceives volume, and so they build the devices like that, so that when I twist the knob halfway on my hi-fi, I may have doubled the amount of resistance on it, for example. So don't buy a logarithmic, get instead a linear, because your joystick axis, you want it to be is that when I move my joystick a quarter of the way, I get a quarter of the resistance reading on the Teensy, right? And the way you can tell whether something potentiometer is logarithmic or linear is, I don't know if you can see, but written above here there is a thing that says B10K. Now what the 10K means is that this is a 10K ohm potentiometer. That's the resistance, but the B part is what tells you that it's linear, right? So that's what you're looking for. So when you buy these things, make sure you get linear ones. Okay, so let's talk about how these actually work and how you wire them up. Now they've got 3 probes. What do they do? Well, the center probe is ground, right? That's your common. We're going to hook that up to the common on the Teensy, and so I'm going to hook that up to my multimeter right now. There we go, hooked up black to common. Now what about the other two? What the other two are going to read is the resistance on that side. So in other words, if you hook up this left one, what's going to happen is when I have it turned completely to the left, I will be reading 10K over there and 0 ohms over here. And if I hook it up the other way, so I put it here, then I will read 10K ohms here and 0 there. So it's really about whether you want it to be left maximum or right maximum. You can hook it up essentially whichever way you want, because later in the code that we write for the Teensy, when we do the firmware, we can compensate for that. But let me hook it up to the left just to give you an idea, and then I'm going to turn it completely towards that side. And now let's set our multimeter, turn the backlight on, we're going to set it to read ohms, and now let's see what we're reading. So we're reading 11.93 kilo ohms, so that's 12K. Now even though it says it's a 10K potentiometer, this is not the highest quality potentiometer in the world, so it's got some degree of error. This one has, you know, whatever it is, 20% error to it. That's totally cool. In the software level layer later with the Teensy, we can accommodate for that. Now watch what happens as I turn it away from maximum. You notice that the resistance begins to drop, right? Now we're down to 10K, 9K, and you can kind of keep going and it'll drop, 4.5K, until when we get all the way to the end, we are at 2.3 ohms, right? So at the very left side it's 2.3 ohms, and at the maximum side it's giving us 12K ohms. So there you go, right? That's all the Teensy needs. It's going to read that resistance value, and it knows how far you've pushed your joystick or dragged your mouse or whatever it is, right? And that's how you use a potentiometer for doing these analog inputs, right? Super simple. Connect the center pin and then whichever one you want. So let me show you what happens if you connect the other pin. So let's set it to max. It's reading 12 kilo ohms now. So let me switch it over to the other side. And now it's reading 2.7, which is pretty much the minimum. And now as I start turning it towards the side that I've hooked up, you'll see that the number grows, right? There we go, until eventually when we get there, all the way to the end, we're going to be reading basically 12, right? So the side you connect really just determines which is your maximum side, and then the other one is the minimum side.